Hello everybody, sorry that I'm not in class today. The reason I'm not in class is my wife's aunt passed away on Friday, and today's the funeral, so I gotta go attend that. Here's what we're doing today. We're doing derivatives of natural log today. We'll cover pages 3 through 8, and you have some homework in front of you for that as well. I'll check with Ms. Schwartz. I'm not sure if I'm checking any work on block day from your pre-calc review, but I do want to highlight that you do have tomorrow a very, 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 very important pre-calc quiz. So make sure you are ready for that. Hopefully you worked on the pre-calculus review as was strongly recommended prior to your 3-day break. Let's go and get going here. Actually, let's do one more thing here. So we got a quiz on 2 sections, but it covers a lot of content on Friday. And then we're going to have a test on 5.1 to 5.4 on February 7th. And this is, we revised the way that we're doing this. We made new packets for you guys this year. We also went ahead and we did, we shortened the packets. We're making it more targeted towards AP. Hopefully we can see those benefits collectively, both you and me, and Ms. Schwartz, and her kids, and everybody. Okay, so here is packet number 1. We're going to do logarithms, exponentials, and inverses. What we're doing in this video, taking the derivative of a natural log, and that's it. And differentiate using log rules. That's it. So, those of us that have had the opportunity to see this before may already know what the derivative of a logarithm is. The derivative of ln of x is equal to, and I'm not going to tell you. You can write your answer below, though, because you'll get it eventually. And you can go and read this. I think many of you can relate to this. As many of you know, I do not like to give answers to my students, especially when I want them to think about it for themselves. So I do the same thing with my 3-year-old daughter. Like one time she asked me, "Daddy, is this how you use a knife?" And she was holding this massive knife. And I said, "I don't know. You just got to keep trying and you'll get it." And that ended well. I do digress though, so as such, I would like you guys to kind of just see if you can sketch what the derivative would look like before actually knowing what the derivative is. Here's a graph of ln of x, and I'm looking for the derivative graph. Let's get rid of that, because that didn't carry over. So again, I'm looking for the derivative graph. Please pause the video and try to draw the derivative graph. You can ask a partner, group, etc. Okay, your answer. All of these values are positive values. Your slope values are positive, which means that your derivative is going to be above the x-axis, and it's going to start pretty steep, and it's going to drop, and then level out to basically nothing. That's a horrible looking graph, but that's basically what the graph looks like. Okay, it kind of looks like the graph was just flipped around and then moved up. Let's see what's at the bottom of this page. Now check with your neighbor, then below describe why your sketch must be the derivative. So an answer, and again, please pause the video before I give you an answer. So pause the video, check with the neighbor and see if your sketch looks accurate. Please also see if you can describe why your sketch is the derivative of r of x. And r prime of x everywhere. It also means that because r of x is concave down, that means that r prime of x is decreasing. You may also hear my wife calling out my daughter's name over and over again. She's trying to get her dressed downstairs. So now, graphically check your answer on your calculator. So let's, I don't have my calculator on me, but you're welcome to do this on your own. Let y1 equal r of x. If you're not sure what r of x was, that was equal to ln of x. And then make sure in y2 you do d dx of y1 with x equal to x. Okay. Now, if your sketch is correct, good job. You should graph this again. So make sure you graph to check your sketch. And it should look approximately like what you drew. Okay? Now, also on your graphing calculator, let y3 equal 1 of x. So again, you should hopefully have two graphs, one like this. You should have another one that looks one like this. That's what green is y1, red is y2. Now it says y3 equals 1 of x, and go back to your y equals and deselect y1, which means that now y1 should no longer be seen. Okay, y1 should no longer be seen anymore. And now we're going to go ahead and enter y3 equals 1 over x. And 1 over x kind of looks like this. I'll put it in blue. It looks like this and like that. That's y3. Now, if you look at the table values for y1 and y3 should be about the same. The derivative of ln of x, and the point here is the derivative of ln of x is equal to 1 over x only when x is positive. I hope you noticed that when you looked at the table values and you compared the table values from y2 and y3, so you should be looking at the table values for y2 and y3 if you didn't already, and you should have noticed that these two values overlap, and basically this black part does not exist in the derivative part, which means that x is only positive. So, to partially conclude, when x is positive, the derivative of ln of x is 1 over x. Now, I have a proof on the next page, and we're going to do some examples with this, but the general idea here is we graphically saw that the derivative of the natural log of x is 1 over x, but only the right side of 1 over x, not both sides. We have one more concept that we need to cover, which is monotonic. Please pause the video and talk about with your group what you think monotonic means. Okay, so I'll tell you what monotonic means. Monotonic means basically the band, one direction. And what I mean by that is that the function is either only increasing, or we say strictly increasing, or strictly decreasing. And we will always do that for its entirety, for the entirety of its domain. You jot that down. That word is really important, and I want to make sure that you remember that one. Monotonic is something that you might hear again and again. Or you might read it in a problem and be like, what's monotonic? One way that students have identified what it actually means, and maybe you've done the same already. Mono means one. Tonic means kind of like one tone, one direction. One direction nowadays. Let's just take a little detour here. Did they break up? Did they go in two directions? Let's see. Oh, they're back in. They got back together again. Now they're going back in one direction again. Interesting. Okay. Here's a proof of the derivative of natural log of x. The only reason I put this there is number one, it was fun to look at and see. Number two, though, is that I just wanted you to see it. I don't like giving you a formula like the derivative of ln of x equals 1 over x without actually showing you where it came from, even if I don't explain it. I just want you to see it. So that's all. That's all this page is. Please also keep in mind that I need to go over this for arguments. I want to make sure you know what that is. Okay. Each of these x squared plus 1, and the root of x minus 4 are all arguments. And we're going to solve each one. Now, we also just found out that the derivative, that's not what I want. The derivative of ln of x is 1 over x. Well, then that means that I can apply log properties here. I can do the derivative of 2 ln of x, which is equal to 2 times 1 over x, which is equal to 2 over x. Now, there may be some of you that may not have needed all those steps, and that's totally fine. But I showed those steps just because I could. Please note there's a different way of doing this problem. You could have also used a chain rule here, where you could have done 1 over, instead of x, 1 over x squared, and then you multiply times the derivative of the inside, which is 2x, and when you see what that simplifies to, OMG. Oh my function god. It's equal to 2 over x. Cool. Great news. So I'm going to skip down to here and tell you what the derivative of natural log of an argument is. The derivative of the natural log of the argument is going to be, and this is how I always want my kids to remember it, is going to be equal to 1 over the argument times the derivative of the argument. Or, if you have something in natural log, it's 1 over u times the derivative of u. So now let's go and do the next two problems. The shortcut that we have now is we do 1 over the argument. Oh boy. We're going to do 1 over the argument. No, you're going to do over the argument. No, you're not going to do over the... Just kidding, we're arguing. You guys probably don't like this right now. Okay, so we're going to do 1 over the argument, which is 1 over x squared plus 1, times the derivative of x squared plus 1, which is 2x. And you get 2x over x squared plus 1. Okay, for the next one, let's do the same thing. We're going to do, since we're doing the derivative of natural log, we have to do 1 over the argument of natural log, which is root x minus 4, and then times the derivative of root x minus 4. And the derivative, just as some side work, of root x, remember, is 1 over 2 root x. And if you're not sure, ask a neighbor. So 1 over 2 root x. The derivative of negative 4 was 0, so there's nothing else there. And I could rewrite this as 1 over 2 root x times root x minus 4, just so it's one fraction. And that's my answer. So again, the derivative of natural log is going to be 1 over the argument times the derivative of the argument. Okay, now we have a couple more problems to do, which are a little bit trickier. So we got 5 problems out of 4. Let's go. I would recommend you to pause the video now and try 1, 2, and 4 all on your own. 1, 2, and 4 all on your own, and I'll walk you through 3 and 5. Okay, here's your answers. Example 1. We have u and v here. We had to do a product rule. And hopefully you got natural log of x plus 1 or 1 plus natural log of x. And I showed my work here at the top just so you could see how we got that answer. And I will always show that for a product rule just so I'm not confusing it, especially if it's a long, complicated product rule. For number 2, I could have done 1 over the argument, which would have been x plus 3 over 2x times the quotient rule. That's fine. And I would have ended up with this answer. Or I could have applied log properties, which ends up with this answer. Either one would be fine. And again, please make sure you're aware that you can solve it both ways. I will always resort to log properties. I'm going to write that down because that's so important, actually. I will always use log properties when I have a chance. Okay. Next. Okay. So that's the same thing for 4. So I did the log property here, and I did a 1/2 in front because I can. That's what happens when there's an argument to an exponent. The 1/2 stays out in front. 1 over the argument times the derivative of the argument gets you x over x squared minus 1. Hopefully you got all those correct, and if not, please pause the video, rewatch it again. Make sure you're being proactive. Even if I'm not there, you can and you are able to get this, but you have to have the interest and perseverance to do so. Let's take a look at number 3, which is a blast from the past, a limit problem. Limit as x approaches 2. Well, let's look at the left-hand limit, because we need the left and the right hand to be the same. The left-hand limit, we're going to look at this value, which is equal to ln of 2. Let's look at the right-hand limit, which is going to be the blue value. And if I plug in 2 here, I'm going to get 4 ln of 2, and I hope you tried that on your own. Oh no, they're not equal. D&E. I like D&Es. They're cool. Let's go to number 5. This is a derivative problem. This is not a limit problem. This is a derivative problem. A sheep dressed in a wolf's clothing. Nothing to fear. Here's why. F of x is ln of x. And the way I know that is because, remember, f prime of x is equal to, I think it was on the other page, the limit as h approaches 0 of some function with some number plugged in with an h minus that function over h. And I just want you to be aware that x can be a number. That's not the color I want. X can be a number, and that could be a number. And that looks like what I have. ln is my function. And if I need f prime, let's get f prime. F prime of x is equal to 1 over x. Now what was the number? Well, the number that they had plugged in originally, this number, looks like they plugged in e. Yeah, I need a smaller highlighter there. The number that they plugged in here was e. So I need f prime of e, which is equal to 1 over e, and that's my answer. If you try to solve that with the limit, if you're trying to solve this problem with the limit, your efforts are going to be futile. That's going to be a tough problem. That's it, guys. I was a minute over for 15 minutes. Thanks for watching, and please, 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 again, if you struggle with anything, and this is for any class, don't just watch the video once and expect to get it. Watch it again, listen to the parts again, and make this, use the advantages to watching a lesson on a video, which means watch it again, pause, etc. Thanks for watching, guys.